So this video is about problem number 6, where I have to get equilibrium of an index. So I just started a video, I got a call, so I deleted the previous video. So equilibrium in the sense like if left sum is equal to the right sum, then it is called equilibrium. So so if we take this array as an example, this is a midpoint. We can see these two results -1 and these three elements will give -1. So the left part is equal to the right part in this case. So we will be returning this element as so this element will be returning as equilibrium index. So basically this problem can be solved by two for loops. So basically first for loop will start from this element and iterate throughout all these inner loop, and it just looks for whether the current index is picked up by the outer loop is equilibrium index or not. So this is going to be pretty straightforward solution, but due to the complexity, I mean, since we are using two for loops, that's going to be big O of n square. So the time complexity is going to be big O of n square. And the space complexity wise, I don't think we're not using any space. So we will be using a constant space. So the second one is like what I wanted to have is like I need to get the total sum of this array first, and then I will iterate throughout this array, and then while iterating this array I will update the left sum. So basically left sum will be initially so left sum I will be initialized to 0. So what I'm going to do is like I will get the total sum of this array and I will iterate through this array and I will update the left sum. So this is already set to 0. So while doing it, we just we can get the right sum because right sum will be subtracting the elements one by one. So the solution is going to be like, so we'll be initializing left sum is equal to 0 and we need to get the total sum. Since we don't want to use any functions which is called sum equal to a, I would like to get the sum by using a for loop. So first I would like to have a function called equilibrium. So this is gonna take array as input. So before assigning the left sum, we need total sum. So total sum is equal to 0, and I will be using for I in range 0 to length of a minus 1. 0 to length of a minus 1. So while traversing, we will just update the total sum here. Total sum equal to total sum plus a of I. So after ending this loop, we will so this is just like getting the total sum because we don't want to use any external function. So I just wanted to have this for loop. So now we will be having a total sum, and then we are initializing left sum equal to 0. So now I will be iterating through the array, and for each index what I'm gonna do is like I will just deduct the sum to the array of this a of I. So for that, what I'm gonna use is I can use enumerator function in Python. So let's say for I comma num in enumerate of a. So this function is what it does is like it just assigns an index to each element. So we'll be using it later. So now we already have a total sum here. So total sum equal to like I said, I will be deducting the number. So total number minus number, so number which is here, so this is the one. So now we will be using if clause where I have to check if left sum is equal to a sum. Then I will be just returning the index which is I. So there we're gonna use I. So the condition is gonna be if left sum is equal to total sum, we will be returning I. Return I. Otherwise we just keep adding it. So total number equal to left sum plus num. So if we don't find in this loop, we will be just returning -1. Okay, so if we see this as an example, it starts from, so we will be getting total sum here. So the total sum is minus, so this is like already -1. This will be 1, and then okay, so it looks like it's 0. Okay, let me double check. -1, 2 minus 1, 1, 6, 7. Okay, so the total sum is already having a 0 here. So we will be doing a for loop here. So for total sum is equal to total sum minus number. So we'll be doing -7. So it is 0. So left sum is not equal to 0. So we'll be traversing through the list. So while till the end, I mean we do till here. So if we just traverse, I mean we just use our for loop, and then we do the rest. We do the same process for rest. After the end, we just get the left sum equal to right sum, and I is gonna be looking at number 2. So we'll be returning number 2 in this case. So since we are using 2 for loops here, it's gonna be big of n time complexity. Space complexity as usual, it's gonna be 0. Yeah, this is like one of the common scenario that we can use for this kind of problems.